Alright, so Dr. Hamali, here we have an electric motor. This one's brushless. So, more or less it's a pretty simple system. Everything is built in a series circuit. Battery packs here, controls here and here. This can adjust our current for us. Power on off, potentiometer to adjust speed, and of course the motor itself. So, the theory behind the electric motor is based around the idea that there is a distinct interaction between forces, and so if you have an electric force and a magnetic force, they can interact and create additional fields of force. So what happens here is current, which is created through the flow of electric energy, is going to flow through here into the brackets, and between the brackets we have our magnet, and the magnet is going to be exerting a magnetic field. It's going to be attracting this to it, and that's going to interact with the electric current flowing through here, and is going to result in the rotation of the motor. And so, when you have the electric motor, you have the various forces that interact. The forces that interact can be used to create kinetic energy that allow for motion, which is how we can power all sorts of different types of objects. This is pretty simple design, actually. Well, can you come in closer so you can see the thing? And so here it is in perpetual motion. Current, force of magnetic field, and movement produced by the interaction between the two that can be used to power everything from a fan to a car. And if we are very careful with the potentiometer, we can adjust the speed without stalling it, preferably. And of course it's going to keep wanting to stall now. Why are you on such a hair trigger today? Wasn't doing this 5 minutes ago, but of course it's going to do it now. So I think a lot of this is the heat buildup that I'm dealing with right now. Well, the point is that as resistance fluctuates, so does current. And with more resistance you have less current, and so the coil doesn't move as quickly. So now we're going to run it in the other direction, I hope, because it's been giving me troubles. Coil keeps getting out of balance, I really don't know. This is where it is. You piece of junk. And there you go. Sorry about that. And so, as you can see, since current is reversed, the magnetic field, however, remains constant, and so the direction of the force is reversed from going down into the board from up, so the current is going to be revolving around through here now. And we will try the potentiometer again. And we can see that there is a speed change. It is more notable as we speed it up. There. And in theory, as long as our power source holds out, since the interaction between forces to create kinetic energy will be the same, the motor will continue to run indefinitely as long as batteries hold out and nothing burns out, obviously, which, to be honest, I'd be a little bit concerned about. And I've adjusted it too much, which will burn it out and cause it to stall like that, fortunately. But the point remains that the thing can function again. We can reverse the current. We can send it in the other way again. There you go. Current changes direction. Is no longer flowing this way, but flowing this way, positive end. And so now it's going to flow around like this, and you can see it's doing just that. We can adjust our potentiometer here very carefully and slow it down ever so slightly. And when we adjust the potentiometer again, it picks up the pace again. Oh, this is lovely, lovely. And that slows it. And I think I just stalled it. Yeah, I just stalled it. But, there you go. The real difficulty we've been having with this one, I'll switch the power off so I don't shock myself on this thing for the third time, is that this coil doesn't want to stay in balance, but unfortunately I am out of copper wire to work with, so we have what we have. I'd like to try it with a smaller coil. I think it might be a little bit more successful, so I might see what I can salvage. But in any case, the motor itself runs just fine. Potentiometer works to adjust speed by adjusting current. That's really it. The whole thing is pretty simple. Electricity flows through, interacts with magnetic field, and changes direction of force.